Hi everyone, I am Rachel Prashant and this is my Teach 1 assignment on question 4 of TukeyCharts. This presentation was prepared as part of the HAP 725 course, Statistical Process Improvement, taught by Professor Farouk Alemi at George Mason University. I just want to briefly describe what TukeyCharts are. So it is a type of chart useful for analyzing single observations per time period. And these charts are not affected by the presence of outliers, as they are based on median distribution. Here, we calculate the median and the fourths, which include the upper fourth that represents 75% of the data and is otherwise referred to as the third quartile, and the lower fourth, which represents 25% of the data and is also referred to as the first quartile. Then we will also have to determine the fourth spread, which is the difference of the upper and the lower fourth. So question 4 asks us to analyze the death rate of CABG surgery patients. We are to use the complications and death hospital file and include the measure ID MORT_30_CABG. We will have to compare the performance of George Washington Hospital in terms of the mortality rate of patients who underwent CABG surgery here to its competitors, namely MedStar Washington Hospital, Virginia Health Center, and the Inova Fairfax Hospital. The denominator in the data set indicates the number of cases, while the numerator reports the risk-adjusted mortality rate. The data that was used for this assignment was downloaded from the data.cms.gov website, which is indicated here. I downloaded the most recent zip files for the time periods from 2015 to 2020. I have displayed an example of two of these files here, but you will also need to download the files for the years 2015, 2016, 2017, 2020 as well. We will be working with the complications and death hospital file for the years 2017 to 2020. And for the time periods 2015 and 2016, we will be using the readmissions and death hospital file. So you will need to save these files as we will need it for the analysis. Next, I imported three libraries, Pandas, NumPy, and Matplotlib into Jupyter Notebook. And in addition, the code pd.set_option, it helps in displaying all the columns in the data frame. Then I went ahead and imported the data from years 2015 till 2020. And below there you can see the output for the year 2017, but you can go ahead and check the data for all the time periods. I displayed part of the data for the year 2020 just to emphasize that some of the column names like provider ID, hospital name, measure start date, and measure end date were replaced by facility ID, facility name, start date, and end date for the years 2019 and 2020. You can see them in the upcoming slides as well. As a question asks us to analyze the death rate of CABG patients, we have to filter the dataset to include only this measure ID, MORT_30_CABG. I have included the code for all time periods, although I have displayed the output for 2019 alone. As you can see, our data frame consists of only the desired measure ID. I have filtered the data frame further to include only the desired columns that we'll be using for the comparison. I have displayed the data frame for 2019 and 2017 just to highlight the difference in the column names for both these time periods. Now we move to filtering the dataset to include only the 4 hospitals, namely George Washington and its competitors, namely MedStar Washington, Virginia, and Inova Fairfax hospitals. I have included the code for all 6 time periods, and once that's done, we need to check the data types of all the data frames. I have included the data type for 2019, and as you can see, the denominator and score has a data type of object, and this should be changed to a numeric data type for calculating the average score of the competitor. Once that's done, we calculate the average score by dividing the sum of the product of the score and denominator of each competitor by the sum of the denominator of competitors. The ILOG 1:4 clause in the third line denotes that we are only including rows 2 to 4, namely the competitor, and the dot clause indicates that we are multiplying each score in that row with the corresponding denominator for all competitors. I have included the codes for years 2015 and 2016. You will also need to repeat the same code for years 2017 to 2020. I have displayed the average of the competitors for all 6 time periods below. Now we create a table that contains the mortality rate for George Washington Hospital and its competitors, and we do this by sorting by year, and the reset_index drop is equal to true is meant to assign new indexes to the table. Next, to determine the lower and upper quartiles, you would need to first sort the competitors from lowest to highest, and once that's done, you can use the describe clause to display the summary statistics of the data frame. As you can see, 25% indicates the lower quartile, while 75% indicates the upper quartile, and the 50% mark indicates the median. We will be using the lower and the upper quartiles to calculate the vote spread. Now we calculate the vote spread by subtracting the lower quartile from the upper quartile. The upper control limit for the peer organization is calculated by adding the upper quartile to 1.5 times the vote spread. In the same way, the lower control limit is calculated by subtracting the upper quartile and 1.5 times the vote spread. We can now move to plotting the Tukey control chart. The observed line, which is blue, is the data for George Washington University Hospital, while the control lines in red are the values for the competitors. As you can see, the CABG mortality rate has been rising above the UCL since 2015, and it has been the highest in 2018. So we can say that overall, the death rate for CABG patients in George Washington University Hospital is worse than the other 3 competitor hospitals. Thank you for watching my presentation, and I hope you enjoyed it. Please feel free to reach out to me if you have any questions or concerns. Thank you.